Hi Year 3, happy Friday. Lovely to be at the end of another week. So I hope you enjoyed today's lessons, and I hope you have a really lovely, relaxing weekend as well. So here we're moving on to angles 2, Year 3 angles 2, our second full angles lesson this week's been really good looking at shape and angles. I love this subject. So today we're having a good recap of what we learned yesterday first. Acute and obtuse angles. Can you remember if an acute angle is smaller or bigger than a right angle? Shout it out, smaller or bigger? Smaller. Can you remember whether an obtuse angle is smaller or bigger? Remember the ob, the b for big, will makes it bigger, okay? So, lots of lines being drawn here. These aren't angles, but when you join two lines together, they make angles. Have a look at the top ones and have a look at the bottom ones. Which ones are obtuse and which ones are acute? If we look at the top ones, we can see they are all smaller than a right angle, so they must be acute. They're acute because they're small. And whereas the bottom ones are all larger than a right angle, they are obtuse, and we have the B in obtuse for big. Angles that are less than a right angle are acute, angles that are greater are obtuse. Okay, sometimes it's not clear because they've been rotated, and we had a look at this. Okay, so when we rotate it, it's much easier to tell. We always need a horizontal line across the bottom to be able to tell whether it's greater or smaller. If you didn't have a right angle handy, then you could always use the corner of a book. The corner of a book, the corner of a piece of paper, because those are right angles. So you can always have something to check whether it's bigger or smaller. There's always a comparison in the room for you, because there's right angles everywhere, as we saw the other day. You have a look here, you can see this one's obtuse because it's bigger than the book. So your task is to sort each angle into the correct set. Remember, you need to log in for the first level of My Maths and get onto the lesson yourself. Okay, so sort each angle. We can see this one. I'm not actually going to compare them to the right angle. I'm going to see if I can do it by eye. And this one's very easy. We can see it's smaller, it's acute. This one, smaller, must be acute. This one's smaller, it must be acute. This one I am just going to check because it looks only slightly different. Oh, it's definitely bigger though. Obtuse, obtuse, and obtuse. Now this slide's harder because we need to rotate it. Now, you could still do it by eye. I can still see that angle, what's yellow, is very small. But if you needed to check, and it's always good to double check. Oh, it's very hard. It's actually quite hard to use this program to do this. Okay. Oh, here, that's it. I can do it with this angle. We can see that if I rotated the right angle onto it, it's much smaller. But it's still hard to drag. I think my computer might have crashed. I'll have to drag it by this. Okay, so that one's acute. I can see this one, if I were to drag this onto here, okay, as long as one line joins up, even if it's not horizontal, because this line isn't horizontal, it's going slightly upwards, okay, we can still see that that one's a lot smaller. Same with that one. Let's have a look at this one. Okay, I'm going through this quite fast because there's other things to get through today's lesson. This one's bigger because you can see that you get to the pink line. If you follow this one up, you get to the pink line, which is the right angle line, before the other angle line, the orange angle line, I'll call it. So obtuse, and these are also obtuse. I'm not going to go through them all, but remember, you should take the time to have a go on your own. So we can put these angles in order of size from smallest to largest. Okay, we're comparing them. I can see this one is smaller than a right angle because if we had a vertical line, it would go right up. And this one is also smaller than a right angle, but I can see this one's slightly smaller than this one. That one must be there, that one must be there, and this one I can see is an obtuse angle because it's larger than a right angle, so that one must be the largest. And there's another one here. We can see this one is an acute angle, that one's an acute angle, but this one's slightly smaller than that one, so this one must be the smallest. This one's still an acute angle, but it must be the second one. Now I can see that these are all actually obtuse, because this line, if I carried it on, it wouldn't be going straight up, okay? So if it was going straight up, it'd go up here. So this one must be still obtuse, but I can see this one's more obtuse than this one, so it must be that one, then that one, and then this large obtuse angle right at the end. So shapes, when it comes up, hello program, shapes have angles, okay? Here is a triangle, and all shapes can be called polygons. Any shape with a straight side can be called a polygon. Polygons have straight lines. We know that a triangle has 3 straight lines. And angles. Anytime 2 straight lines meet at a point, they form an angle. So we can see the triangle has 3 because it's got 3 lines and they join at 3 different places. And they're all inside the shape. Here's another polygon, a hexagon. You can see that it has 6 lines all the way around it. It also has 6 angles. Okay. If you want to, you can shout out whether these are obtuse or acute angles. Here are some more polygons. Is there a relationship between the number of sides and angles? We can see that the triangles have 1, 2, 3 angles and 3 sides. We can see the square has 1, 2, 3, 4 sides and 4 angles. So do you think there is a relationship between the number of sides and angles? Yes. There are inside angles, there's angles inside the shape or the polygon. There are always the same amount as the sides. So a triangle has 3 sides and 3 angles. A hexagon has 6 sides and it has, as we saw before, 6 angles. So remember, a polygon is only a shape with straight sides. If it has a curved edge, it can't be called a polygon. But this shape has 6 straight sides, so it's still a hexagon. It doesn't look very much like the other hexagon we saw, but it's still a hexagon. It still counts as a hexagon. The sides are different lengths, whereas the other one, all the sides were the same length. This has different length sides. Therefore, the angles must also be different sizes. Okay, so we can see these angles. That one is much bigger than this one. This one is an obtuse angle. This one's an acute angle. But because there's 6 sides and 6 angles, it's still a hexagon. And we would call it an irregular hexagon. Okay, an irregular hexagon. Polygons can be regular and irregular. Regular polygons are shapes where all the angles and all the sides are equal length and size. So this is an equilateral triangle. We can see all the sides are exactly the same length, and therefore all the angles are exactly the same length. Okay, all of these are regular polygons. Okay, all of these are regular. Irregular polygons don't have sides that are equal length. So we can see that this is a very long side compared to this one. Still has 3 angles, but they're all going to be different sizes because of the length. We can see lots here. We call them all. They're still pentagons, they're still octagons, they're still nonagons, which is 9 sides, but they're irregular. So let's sort them into regular and irregular. That one I can see it's got nice equal sides. The same with this one, which is a 1, 2, 3, 4, 5, 6. It's a hexagon. Oh, it's not. It's a septagon. 1, 2, 3, 4, 5, 6. It's got 7 sides. But these are irregular. because you can see that not all the sizes are the same size. We can measure the angles to check whether it's regular or irregular, okay? Because if the angles are all the same size, then we know it's regular, okay? So as well as measuring the sizes of the lines to check it's regular, we could also do the angles. Let's have a look at this pentagon. Every single side is being measured. Do you think it's regular or do you think it's irregular? Have a look at the angles. Do they look different or do they look the same? I'm hoping you all knew it was regular. All the angles are the same side because all the lengths of the sides are the same. Here's a quadrilateral. Let's measure the angles. That's one angle side. Another one. They look quite similar. Ooh, but that one looks a bit bigger. And that one looks a little bit smaller. Well, that one's bigger than this one. They're all different. Therefore, it must be called an irregular quadrilateral. And we can see that the sides are clearly different lengths. This side's tiny compared to this one. So, you can measure angles of a regular pentagon. Not a pentagon, it's a quadrilateral, sorry, and you can order them. We can see that this one is an acute angle, this one's also an acute angle. If I put it there, we can see it's an acute angle, but it's a bit slightly bigger acute angle. This one is an obtuse angle, we can see it's a little bit bigger, but this one's even bigger, so that one must be the largest. So 2 acute and 2 obtuse. So hope you enjoyed today's lesson. Keep on thinking about angles that are around your house. Maybe you could draw some different shapes, label them if they're regular or irregular, label the angles, keep on working really hard like you are, and also log into MyPortal to do your work. I hope to see you next week. Hope you have a lovely weekend and take care.